Hello again, so I'm back with the exact same problem. I went ahead and erased things so I actually had room. These are the two formulas dealing with geometric sequences and series. This one actually is in terms of sequence, this one is in terms of a series. There's your stipulation. And I want to take this and I want to write it in sigma notation. So let's just pretend all you can actually see is the blue. 6 plus 12 plus 24. And it says, write in sigma notation of a geometric series. That's not too bad. Now you can always reference this just to make sure it's right, but here's how I would start it. First of all, I would say I would use the variable I. You can use any variable you really want, but that tends to be common. And I would assume that it's 1. Now I suppose you can reconfigure things and say, oh, if I go from 2 to whatever and do this, and then but no, actually that's probably too cumbersome to even think about. So just do it this way. Now there's 1, 2, 3 terms. So if I'm going to substitute in 3 values, it's going to cap off at 1, 2, 3. So there we go. Now my common ratio is R, which means to get from one term to the next, I got to multiply 2. Now it's no coincidence that the number that's the base of the exponent is the same as the ratio. Bam. So what I do is I just write 2 to the I. Now there's a problem with that. 2 to the 1 will not give me 6. So 2 to the 1 will give me 2. So what do I have to multiply with that to get a 6? 3. 2 to the 1 is 2 times 3 is 6. 2 to the 2 is 4 times 3, which is 12. 2 to the third is 8 times 3, 24. And then it would ask you to add them all up together, and that was 36, 42. So that said, I hope that was helpful. I think it's actually pretty deserving of its own lesson because students struggle with this initially. They really do. And I don't blame them. This is a little intimidating when you first look at it. But once you get the hang of it, it's not so bad anymore. Okay, with that said, have a great day. Goodbye.